interesting. We should be live, no? I guess I don't really need this. Cool. How am I sounding, chat? A lot of tests. Yes. Many tests. I needed like a long stream of content. Hi, Tez. And hi, Kat. You may have noticed that I kind of rearranged things here. We've got chat up here overlaid and me down here in a little circle. Yeah, I'm in a bubble. But it's cool though, because look, I can float around. I can even like point at things. I think it'll be fun, no? So, yeah, we'll give people a few minutes just a couple minutes to get on. What language do I use on my day job? I use mostly Swift and TypeScript on my day job. I'm a front end. I'm like the UI guy on both like the web front end and iOS, macOS front end for a company. So is coding hard? Anything's hard. Anything can be hard, anything can be easy, I think, right? So like if you've never done it before and you try to jump into doing something hard, then yeah, it's hard. But that's true about everything, right? And I don't think it's a particularly hard thing to get into compared to some other things. Just the more you do it, the easier it gets. I'd say, but other people might have other opinions. It sort of gets has a reputation for being really complicated just because like if you don't understand it, it looks like total gibberish, right? But if I look under the hood of a car, it looks like total craziness to me, and so that looks really hard to me, you know. So we'll give one more minute or so. People are still trickling in, and then we'll jump in. By the way, is the audio level good? Am I loud enough? Too loud? Too quiet? Rust seems so complicated. Rust to me has been pretty manageable until you get to like lifetimes. Like lifetimes to me are like killer. Also the bar checker is pretty annoying. Aside from those two things, I feel like it's fairly straightforward. But I haven't done very many advanced Rust things. And I've hardly done any like concurrency stuff, which I hear is also a headache. You stumbled across my channel yesterday. I'm on your first year of computer science and learning about computer architecture, so it's interesting to hear you talk about compilation process and ISA and whatnot. Cool, that's fun. Nice. Well, yeah, this is my first time writing a compiler, so take everything I say with a grain of salt. All right, we got a handful of folks on, so let's, I guess, get started here. So as far as what to do today, there's a few directions we could go. just as a reminder of what we have, we can lex everything you see here. So this is our language, by the way. Lovely. This is lovely. We can lex everything we have here. We can parse mathematical expressions, stuff like this. Well, most stuff like this. So as far as next directions, I say we could either try to parse all of this. That's probably the best direction. I'm thinking, here's what I'm thinking. I'm saying next, because we can lex all this, but we can't parse all of this yet. So we try to parse all of this. Then, well, except for this, we don't support strings yet. Although that wouldn't be too hard to work in. Maybe we should do strings. Whatever. Okay, so we're gonna parse all this, and then after that, I want to write a tree to the grammar, because that just makes it a joy to look at. I don't know what your decision-making process was when it comes to choosing a language for the compiler, but on my uni, is that university? We use Haskell. Whoa, that's pretty cool. I don't know Haskell. My decision-making process was used like the language that is like fun to use and I know the best. So that was I don't know Rust the best of the languages I know, but it's fun and I enjoy it. So I don't know Haskell. As far as functional languages go, I'm learning OCaml, but we definitely considered OCaml. Yeah, all right, so let's just try to parse the rest of this kind of stuff, right? So what do we have to parse? Or maybe we should step back and do a string, so that might be fun. I don't know. Before we do string interpolation, string interpolation is complicated, no? We're not going to do that yet. Actually, let's just not even do strings yet. I'll say like, whatever, person.length or something. Oh, then we still have to do, okay, so there's no strings. I don't know. How could I replace this with something that kind of makes sense? That doesn't use strings. Okay, I'll say add. Check this out. Okay, so add num to other num. And we're going to return num plus other num. And then the API will be like this. Add 3 to 4. Isn't that a nice API? This is the kind of stuff you got to do when you have this kind of thing going on. So we're going to add 3 to 4 like that. There we go. Now we don't have any strings to deal with, and we can start trying to parse all this. Cool. Andre, I'm curious, what's been your experience writing compilers in Haskell? How's that gone for you? All right, so we need a few more AST nodes, right? So can you slide over there for a second? Okay. So, okay. Statements can be variable declarations. Okay, so there's no, a function declaration isn't anything different now. It's just like another variable declaration, right? So we don't have function declarations. Right, function decl is no longer a thing. Variable declaration is a thing, right? And it should pretty much still be the same, right? Its name, whether its value, which is expression, whether or not it's mutable, and its type. Yeah, that's the same. All right, but then we just have one more kind of expression called function calls are still a thing. Are these the right argument? Yeah, okay. But a function, oh, we don't need this anymore. Alright, so now we just have a new kind of expression called a function expression, right? So I'm just going to call this a function. And then what does a function expression here have, right? So it has a name, which is a string. It has a parameters, which is a vec of function parameters. Now, this doesn't exist yet. Coming soon. And then it has a return type, which is a... what is that? Just a string for now? What do we do for variable decal? Type? Oh, it's a type. Oh, type is a thing. Okay. So we have type. Type. And then we'll do, okay, return type is a type. And then it has a body, which is a vec of statements. No? Alright. Now we make function parameters. Yeah, okay. Function parameters, where do we put this? Probably by argument here. We'll derive these things. Struct function parameter. Now it's happy. What is a function parameter? Well, look, so it has potentially two labels here. Well, it's more of an enum, I think. Right? Because it's either call site labeled. I'll say like labeled at call site, which has certain things, or unlabeled at call site, right? If it's labeled at the call site, then okay, no, if it's unlabeled at the call site, then it just has a name, which is a string, and a type, which is a type. Right, we're using type for type, yeah. If it's labeled at the call site, then it has a internal name, right, which is a string, and then it has an external name, which is optional, right? So we option string, and it has a type still. I feel like that makes sense. Cool. That should work. So now let's try to parse some of these things. So over here, let's try some tests. So we're parsing, yeah, we're parsing like mathematical expressions, which is fantastic. Alright, so let's do like variable declarations. So we'll make a new test. That's basic expressions. I'm gonna rename this to like mathematical expressions. Tester passing, cool. Gonna make a new one down here called variable decals, right? So we're gonna have a few text cases. Expect AST to be, oh wait, I forgot all about our semicolon conversation we had. We decided we were gonna add semicolons to this language instead of significant new lines. Oh dear. Okay, so we need to go back to the lexer. Sorry, forgot about that. We need to work in semicolons. All right, so new language has semicolons because it's gonna make our life easier, we're told. Now, implicit returns like this. See, I'm told we don't need them. Yeah, so the separator is not terminator. Okay, like we don't need that. Right? Separator is not terminators. Like this is, it's like Rust, right? Like this is a return value. This is a return value. This is like the final thing, right? I suppose. Yeah. We'll do that. All right, so new. Go in and revamp our lexer. Tokens. Okay, now we no longer have a new line, but we have a semicolon. This should break everything, as we expected. Okay. Now over here we have errors. Wait, why are there errors over here? Because if it's a semicolon, oops, then we're gonna do this. Coolio. Alright, if we see a semicolon, just make a semicolon. That's pretty much all there is to it, right? And we changed this test case to have semicolons so that we know we're parsing them. We'll do like semicolon there, semicolon there. Right, so take out all these new lines. There's no new line here. There's for we'll have a semicolon. This will have a semicolon. And then z equals x over y. Wait. I don't know. X over y. This becomes a semicolon. This becomes a semicolon. Alright, cool. So now we're good, but we're failing the test. A legal token, and it's not showing it because it's a new line character. That's why there's a new line here, right? So that's because we want to go to here. We want to also skip over all white space. I actually like this better. Cool, and we're already passing. Alright, so that was easy enough. Back to our parser. We now have semicolons in the language. Go to our like test thing here. Also, I forgot to ping the Discord when I went live, so let me do that now. Live ping. And where can I get this link? Right here. Awesome. Okay. So now we're lexing semicolons, and we just need to start parsing more things. So we are going to parse. What are we going to do? Oh yeah. So test variable decals. Yeah. Variable decals. So we'll expect AST. Here's like we'll say foo 4. Here's like our basic example, 432. 4321, right? This should be a program which takes a vec, statements. This particular statement is an expression statement. No, it's not an expression statement. It's a variable decal. Wait, what does this look like? We're missing that. Right? And that. Does this do this? No, it doesn't. Variable decal. This would be nicer. Okay, this would be nicer if it wasn't nested like that. So I'm gonna go over here. Do this. Well, maybe it's fine. Okay, it's fine. Variable decal. You can fill in those struct fields. Okay. The name is foo. No? The value is an expression int literal 4321. Is it mutable? No. And the type? It's none, right? Ooh, but we need to make this optional, because we don't have to specify the type on a variable declaration. So, because it should infer it. Option type. So there we go. All right, and if we try to parse this, then we're getting no prefix parse function for identifier foo, right? So clearly this is not right. Let's go fix the test. No? Or maybe we should write some more first. So let's do a few of these. I think 4 should cover the bases. Okay. Then okay, well, how do semicolons actually behave? Are they doing like the same thing that semicolons do in OCaml? Why is it saying unreachable? Come again? How did me adding these make that unreachable? Wait, what? Oh, because I made this to do. Whoops. 9. There we go. Okay. Hey, do any of you guys know OCaml? Are you familiar with what semicolons do there? And if so, is that the behavior we're looking for here? Okay, and then we'll do like an immutable one. We'll make this one called bar. It'll be, sorry, this will be mutable. Then we'll have another one called typed var, which is immutable and has the type specified. This one is mutable and has this is like immute. Is that even how you spell it? Const. Type const. I'll say const. Okay. This one looks like that. It'll be int like that. All right. This isn't what we're expecting though. So this one would be the same as the other one, except for its name is bar, and it is mutable. This one, it's called typed const. It's called type. Yeah, it's called type const. It's that. It is not mutable, and it does have a type. The type is int. Kind of like that. This one's just like that. It is mutable. It is called typed mut. There we go. Okay. All tests should be failing. Oops. Perfect. All right, and now we need to go. Yes, we're currently only parsing one statement. That's fine because those are all only one statement. What does parse statement do? Gotcha. Okay, how do we know All right, I have some questions about like expressions versus statements and semicolons here. Like, should I have a return keyword instead of that? Or should it be called a ret? Because that's more concise. Maybe. But this is nicer, for sure. But then what would the semicolon? Hmm. Questions. All right, then is everything an expression statement? Like, is this an expression? And the semicolon basically says discard the result. Like, we're only here for the side effects. I think that's kind of what we're going towards here. Semicolon. Okay, I think everything's an expression. This just returns type void. Semicolon says, okay, discard that. It's just like OCaml. Semicolon's for discarding the result. But in OCaml, you can only discard voids, right? Or units, they're called. I kind of like unit better. I think I'm going to do it that way. Because here's the result we want to use. So we don't put a semicolon on it. Here's a result we might want to use. So we might want a semicolon. Who knows, right? So we'll leave a semicolon on that one. Okay, that makes sense. That makes sense. So then... So then what happened if you did something like that? This would be a syntax error, no? Because it'd be like equivalent to this, which is baloney. But that's fine. So then how do I represent that in the AST? Right, because we have expression, everything, we have statements. Turns out variable decals are actually just expressions too. So maybe a program isn't a vec of statements, but rather a vec of expressions. And expressions This is really interesting. Alright, so I think these are all expressions. Everything's expressions. So nothing, we no longer have a vec of statements. This doesn't make sense, right? I'm not going crazy here. Everything is a vec of expressions. Statement just got cut out of the picture. Right? Function bodies actually are a vec of expressions too. Now, an expression result is either discarded with a semicolon or used. All right, like this result, this does a side effect by sticking this value in Z, right? But then the result, which would be void, is just discarded. And then this one is used. So maybe every expression has okay, I think I have it. I think a program is a vec not of expressions, but of expression statements. So expression statement. It does all these things. And then it has an expression, right? That's pretty much all it is. But then it just has one other piece of information, which is whether or not it's discarded, which is a bool. Right? If it has a semicolon, it's discarded. Otherwise, it's not, right? Okay, this makes this very interesting. So this becomes a vec of expression statements. Alright, this totally breaks our parser, but it shouldn't be too bad. The statement is no longer a thing. A statement. Alright, so what do we expect this to be? This should be an expression statement. Right, which is this needs to have public fields. I think it just goes like that, no? And then discarded is false. This is not discarded. But I want this with a semicolon to be discarded true. Alright, this now is totally changed. This becomes an expression statement. Like that. Okay, this becomes an expression statement. That's not discarded. This, maybe just for the sake of doing it, we'll discard this one, you know? Expression statement. This one's an okay, yeah, and then that goes there. This one is discarded. Alright, let's comment this out, or comment this whole thing out, really. Oops. Okay, and then go fix. Statement. So parse. This becomes parse expression statement, which could just be called a statement, because since it's our only. We no longer need this can now jump straight to, this becomes like, okay. Chat is suspiciously quiet. Chat has no idea what's going on. I know, some of you surely do. Parse expression statement. Okay, expression statement. Just gotta think. So everything's an expression statement. So this whole thing here becomes irrelevant. It's kind of what I'm thinking. I feel like half of chat is not following and the other half is like shaking their head in disapprobation. This becomes a expression statement where the expr is this, and the discarded becomes a to-do. Okay. Hey, it's actually compiling now. What? It's actually working, except for the discarded thing. What? The only thing worse than when something doesn't work is when it works and you don't know why. Those are wise words, by the way. You should write those down. So we just need to figure out whether this thing is okay, so yeah, we'll just do it here. This shouldn't be too bad. We'll say like expr equal that. We'll pop in expr here. Add a semicolon here. Then we have like an expect, yeah, this thing. Not that. Back. This guy. So I'm gonna make something that's kind of like this, but it's gonna be called like expect semicolon. Well, I'll do check. it just actually returns a bool. Whether or not the next token is a semicolon. Yeah, okay. If let semicolon equal self dot cur token. Oh yeah, okay. If it is, then wait, can't we just do this? No? Yes, okay. Okay, so we'll say this isn't the best way to do that. What in the world? Why is that fine? Okay, and then we'll just do how about that? Boom! Tester passing. Who would have thought? Will it be interpreted or compiled? Compiled. This is going to be a compiled systems level language for writing an operating system. Alright, can we get this guy going now? We need to fix him first. Okay, statement becomes an expression statement. We don't do this dance anymore. Variable decal. This ends up becoming a type of expression. This needs to be boxed. This needs to be a box. Discarded. We'll do like every other one will be discarded so that we're getting good test coverage. So this becomes expression statement. Also, by the way, Lovely's gonna have real constructors, so you can do stuff like this, because I think that's nicer. Discarded. True. This one is discarded. All right, this one here. This becomes an expression statement. Oops. This becomes that. Yo, Babu Deli. Expression. This needs to be boxed. Type. There we go. Expression fast on Vim. Definitely seen faster, but yeah, I do use it all day long. So, wait a minute, expert. Did I do that right? There we go. And oops. Discarded. True. Hello, I'm new. What language are you using for this? I'm writing this in Rust. This is Rust I'm writing. Yep, Babadeli's got it. Rust probably. Config, like you mean my NeoVim config? To go to my dot files. It'd be like, wait, where would that be? That I think is right. Did I type that out right? Yeah, there you go. This needs to be boxed. There's been much debate about this. Will arrays be 0 indexed or 1? Hey, you commented on my videos, didn't you? I remember your profile picture there. I think there's a really good argument for making something 1 indexed. But we'll see when we get there. We don't have arrays yet. We don't even have strings. Although really arrays are simpler than strings, aren't they? Strings are complicated. Alright, so I think these are good tests. What's the tilde and the function arguments? It, like over here. This means the tilde means in the call site down here, I don't need to label it. So I refer to it by num inside of here, but I don't need to add a label down here. Whereas over here, I have 2 labels, right? One for the inside, one for the outside. So in here I call it other num, on the outside I call it 2. So on the call side it's add 3 to 4. So you can do really cool stuff like that by having customizability in here like that. It's basically still on verbatim from Swift, except for Swift uses an underscore like that. All right. How are the? That's cool. Yeah, I think the main thing is that it just lets you make APIs that are so expressive like this, like add 324. This is like phenomenal to me. Will you be adding bitwise operations since you're planning on writing an OS in this? You're going to need it. Yes, and I've had people tell me that I'm going to run into conflicts using this because this is like the not bitwise operator, isn't it? So we can always change it later, or we can override it, whatever. All right, this is what I was expecting. We got good failures now. No prefix parse function for identifiers. So one thing before, maybe I'll comment out this bottom test here. And so that tests are passing now. Okay, I'm gonna add a test here that's single, I'll call it single value, all right? So I'm gonna add, basically duplicate this. Gotta go, see ya. Isn't C or C++ better for writing an OS? Or at least writing a language you're going to write an OS in? What makes you say that? For what reasons? Expression statement. Okay, so I'm gonna change this to like something like foo, right? So this might make our tests, well, should make our tests fail, right? Okay, here's what I expect. I want this to be an ident foo. Okay, so we get a no prefix parse function for identifiers. Where is that? No prefix parse. Okay. Right here, right? Prefix parse function. So we need to have another one here for ident. Well, I guess we'll have a parse. Okay, here's the oops. Here's the tricky part. So I didn't make anything wrong. No, nothing wrong. I'm just wondering what your reasons would be for, like, what you've heard that has led you to believe that. Like, I don't. Like, one, writing a language that you're gonna write an OS in is pretty different from, like, that'd be a very different choice from choosing a language to write the OS in. Like, I feel like I could have chosen TypeScript to write this language and it would have been fine. But I would never use that, obviously, to write the OS. So it's kind of like two different questions. C and C++ are definitely the most commonly used languages for writing OSs, but Rust is very popular as well. Yeah, writing an OS in C or C++ is definitely easier than making your own language. This is pretty much just for learning and for fun. So, all right, so here's what I was about to say. Check this out. So if I run into something like this, I don't know whether, didn't a fight break out of the Linux because Rust in the kernel? Yeah, I heard there was some drama regarding Rust in the Linux kernel. So I don't know here whether I don't know here whether, like, if I'm sitting here with my parser on foo, I know I have an ident. I don't know whether this is gonna be just like an ident or whether this is gonna be a variable definition, right? Because I don't know what this is. So we need some way to peek ahead and see if it's a thing. Do we have a peek? No. We have a cur. We have a cur token. Hey, this is easy. So we just make a peek token. That does the exact same thing, except it does it at self-deposition +1, right? Any particular reason why use : and : instead of equals for assignment? Well, what I'm doing, I'm using equal for mutable assignment, and colon for, because I could put a type in here too. I'm using colon for immutable assignment and equal for mutable assignment, right? So you'd never later go through these three. This doesn't make any sense because fuse immutable. So I am using the equal for assignment, right? But I couldn't do this for foo. I could only do this for bar, if that makes sense. I'm told this is what Jai and Odin do. So this is like a const. This is mutable, if that makes sense. Okay, now, all right. So now we have peak token. So up here, here's what I'm gonna do. I'm going to match on the peak token. Self.peak token, and then if it's a colon, I'm going to do something different. Otherwise, I'm going to do self parse ident. Is that a good name for it? Parse identifier? Yeah, I suppose. It's just like, yeah, parse ident is good. Hey, Bacon. What's up? Is it hot in Alabama? Parse what? Have I given up learning ASM? No, not at all. Not at all. I just kind of didn't want to wake up so early this morning because I was tired. So I didn't do it. And I was just a little bit overwhelmed too. But I'm totally going to keep doing ASM. It's always hot. You know, ASM's definitely a go. Like, the entire reason I'm making this language is, one, to compile it to ASM, but then to write the operating system, right? Same reason I'm learning ASM. I'm just taking a day off. I also was thinking there's a lot to do with this language, and I feel like if I keep going at my current rate, I'm gonna be like, I'm gonna have a bootloader and everything ready for my operating system way before this language is ready to be used, and so I kind of try to speed up the language development so that I try to hit the same point at the same time with both of them, which is gonna be really hard to coordinate, but it's okay. If that makes sense. So then we'll do like, yeah, parse like variable ident would be good. Now you may have noticed this doesn't exist. Identifier. Don't burn yourself out. Yeah, no, I'm not in any hurry. I wasn't overwhelmed with this stuff. I was overwhelmed with life in general, so I don't have any problem with like taking a break from this. That'd be fine. So thank you though, appreciate it. Parse variable ident. Why am I building these projects? To learn. To learn. Oops. There we go. Yeah, to learn the level of development, I guess, in system programming. And because it's fun. Because I'm an elite hacker. I've never done leak code, Bacon. Alright, so we need to make parse variable ident. We already have, okay, parse int literal, parse int literal. It'll be kind of like this. Very similar. Parse variable ident. This needs to be capital self. This becomes a ident self that expect ident. We need to make that expect int. It'll be very similar to this. Expect ident, except it'll return a string. And then we will say the current token is an int, and we'll call it something else like stir. OS and programming language, these are too much hard. Well, we wouldn't want to do it if it was easy. That wouldn't be any fun. Yeah. Alabama wisdom. Give me a suggestion to get a high-paying job. What should I do? I'm a student. Yeah, talk to Bacon. Bacon knows. I have, I think, $400 in my bank account right now. Okay, this should work, except for we expected a identifier. Parse variable ident. Yeah, okay, this is good. Joink. Oh yeah, it's working, sure enough. Okay, so then go back here and wait, turn this test back on. Now we got it not yet implemented, which is coming from a to-do I have somewhere. This one, right? Okay, cool, perfect. Wow, it's cool really having a parser do what you expect. So if we see a colon, then we're gonna call it to another guy here, like okay, self parse variable declaration. Bacon, I don't know how much you caught from the beginning of the stream, but we added semicolons. They are separators. They're basically, I don't know if you know OCaml, but they're like what they are in OCaml. Like, except for I can use them with things that aren't unit. So like, everything is an expression now, pretty much. Well, yes, everything's an expression. And the semicolon just means like throw away the result, if that makes sense. So like over here, these have side effects, right? I'm assigning for to foo. This is an expression though that returns unit, and then I discard the result. This is an expression that returns unit, I discard the result. This is an expression that returns unit, I discard the result. I discard this result. This is a result I don't discard because it ends up being the return value, right? So it's really a lot like OCaml. If you're familiar with that. So like I could in theory take this off and then it would mean that we use this, but we're not really using it anywhere, so. But yeah, that's kind of the idea. This would be a mistake, right? So yes, but this would parse fine, but this would get caught in the, like this would parse okay, but I think we'll catch it in the semantic analysis step, because it's something you'd never want to do. No return keyword. Well, we're gonna need something like that, because what if I had an if or something, then I need a way to like return out of here, like exit the function. So I don't know, maybe that, or maybe ret, something like that. This leads me to a good question. Would this need to have a semicolon there? I think these would need to have semicolons, which is maybe a little ugly, but it's not too bad. Ret would be nice. Yeah, I think ret is nice because then it's just like assembly too. Are you building these projects to get a job or for another reason? Me? Yeah, it's to learn. Just to learn, not to get a job. Parse variable. Why is this? Oh, because it doesn't exist yet. Okay. So we need to go make a parse variable declaration. So I don't know. Let's take it somewhere in here. Parse variable declaration. The language looks way too modern to have semicolons. Makes it ugly. I've found that since I added them, it's made parsing a whole lot easier for one, and I think it just makes it make more sense in general. They're really easy to type, like Bacon said. I don't think it's too bad. Do I use LeetCode? I've never once used LeetCode in my whole life. Result, expression, or I might error. And then we Bacon does LeetCode, yeah. All right, parse. Where are we sitting at this point? I got to it if I get to here, right? So that means the cur token is an identifier. All right, so we can grab that with expect identifier. Okay, so let name equals self.expect ident. Right, like an error. So now you have a string there. So we have a name, and then we want to. Okay, so I have expect ident, expect int. I want to make like a generic expect anything, right? So expect token. It'll take a token kind, and it'll just either, I don't need to return anything. So it'll return unit, but it might error. What does the to keyword do? Is it like pass back? No, to is not a keyword. This, you can have one label, you can have one argument name, or you can have two. This is just like Swift, if you know Swift, right? And so this is the interior, meaning used inside here name, and this is the exterior name. So at the call site name. So in the call site, I call it to, but in here, I call it other num. So here it reads really nice, num plus other num, but here it reads really nice, add 3 to 4. So it reads really nice in both places. Cool. So then we expect toke says how do I do this? All right, let toke cur token So now we have a token kind. If toke bang equals kind turn expected. Whoops. Okay, so now we expect token. Now I'll say self.expect token. We're expecting a colon. Oh, do that. There we go. All right, so now we expect a colon. So we're getting through to here. Cool. And then, okay, and then there might be a type next, but there might not be a type next. So, oh, okay, but when I expect I forgot to advance. Oh no, okay. I went to advance, else self.advance. Yeah, so now we're on the next token. So then, for the next token, so we'll match. So we'll say like match self.cur token. All right. Now we might have an identifier, right? In which case we need that would mean we have a type. Or we might have a colon, which would mean that we have a const. Or we might have, okay, actually we should really just, okay, yeah, if let identifier name equals self.cur token, then okay, so here I'll say let my type equal none. And then here, so if we have one, we'll say type equals or type, no? Ident name. Some all right, down here I'm going to return an expression variable decal. The name is the name, The type is the type, mutable. The value is a to-do, and the mutable is a to-do. So also in here we'll advance. So that should handle the type. So we got the name, we got the type. The next one sort of determines whether or not it's mutable, right? Hold on, new stream layout. Hey Stefan. Yep, new stream layout. What do you think? Look, I can fly around. I can even point at things. Isn't that nice? And the screen is bigger for you guys, right? It's not. I don't have all the stuff around the edges, so hopefully the font size should be nicer. You gotta make airplane noises. I can do that. I can do that. Next time I fly, there's gonna be airplane noises. All right, so this should handle the type. Also, Stefan, you missed a little bit of stuff going on. I added semicolons. Semicolons basically do what semicolons do in OCaml now. They like discard the result of an expression. Everything's an expression now. Yeah, Stefan, you need to work on your sleep schedule, man. So like this is an expression, and I discard the result with a semicolon. This is another expression. I discard the result with a semicolon. This is another expression. I discard the result with semicolon. This is an expression. I discard the result with semicolon. This is an expression. I don't discard the result because I want it to be the return value, right? So on and so forth, right? It's just like OCaml. You woke up at 5 a.m. and Kai slept in. Oh no, that's horrible. I feel so bad now. It was like the one day I slept in. Okay. So now we need to check the next thing. So we'll match on the self.cur token. And here's the options. Here's the options. If it's a colon, then we know we have a const on our hands. At this point, if it's a equal, then we know we have a mut on our hands. If we have anything else, we have a syntax error on our hands. We want to return an error. Yeah, really good question, Stefan. Like what would happen if I left this off, or if I left this off, or something? Is that what you're asking? Error, syntax error. Or I can do expected. Expected. This needs to be an error. What do you think it should do? I was thinking that would parse fine as just a non-discarded result, but then in the semantic analysis step, which is after parsing, right before compiling or before code generating, it would get caught as an error, because you never want to do that. Sound good? Will this language have a go-to statement? Keyword? I don't think so. Go-to is kind of weird. Not for now, at least. Alright, so now we just need to deal with these cases. So if it's a colon, then we'll expect token colon. We probably could, but as a group on Discord voted to have semicolons. Yeah, it would have been possible to write it without semicolons, correct. But I kind of like the semantics of having semicolons. Like this rusty OCaml thing of having this last one not have a semicolon and not discarding the result. What? Oops. There we go. Well, that's because I think in Go, Pyrotech, I did something like Go where after lexing I go over the vec of tokens and insert semicolons where it makes sense. That's what JavaScript does too, right? Like automatic semicolon insertion, ASI, which I think people generally don't like, right? Because that's only if semicolons are terminators, meaning they have no semantic value except for that they just always end a line, just for the sake of parsing, ease of parsing. Whereas my semicolons actually mean something. It means discard this value. Like this has a value, discard it. It's like OCaml. I can send the Discord link if you so desire. How do I do it though? Oh dear. Here we go. JS isn't a serious real language, yet the entire world is running on it, so what can you say? Alright, so we expect a colon. If it's an equal, we'll expect an equal, obviously. Maybe this is a little redundant. Maybe we could do self.advance. I don't know. And then we will you can make it so your block expression always returns last expression semicolon or not. Yeah, that works too, and that would be another valid thing to do. But I think this way it looks nice. So here, now we just basically need to okay, we need another value. So we're gonna say let mut value equal it's an expression. Value now is used here. This needs to be assigned. If I assign it here, will it be happy? Ducties, you're sub 2,000? You serious, man? We got 2,000? Mine's showing 1,997. Hi, how are you? I'm okay. How are you? Wait, something's really fishy with your approach. Are you now telling me... Yes. No, it's... Yeah, sorry, Stefan. It is everything turned into an expression while you were gone. Z... Yeah, Z colon X over Y. Just returns unit. It actually returns something now. So I changed my mind about being a statement. Are you okay with that? Or do you think that's really bad? Makes sense now? Okay, cool. That's exactly what you were advocating for? Oh, awesome. Cool. So we're on the same page then. Sweet. Yeah, I think it's cool too. So, yeah, they just return unit. Although you could have them like return the value that they get assigned, but that to me feels a little bit messy, and I feel like people would use it for hacky things. I feel like returning unit is better. Cool. So 2,000 subs. That's pretty awesome. Thank you, Duck. So I'm just gonna say value here becomes self.parse expression. Which might error. It needs a precedence. Precedence is lowest. And we do the same thing here. That doesn't need to be immutable. No. What? Clippy's lying to me. Yeah, what are you talking about, Clippy? Clippy, you're full of it. Congrats on the subs, thank you. We could give Duck a 2,000 sub rule, yeah. Hello, Janeems. Yeah, you also join the server. Yeah, Duck, if you join the server, we'll give you special 2,000 sub roll. Okay. So this is fine. It's just Clippy's mad at me, and it shouldn't be mad at me. It's telling me I can just move the... Yeah. Clippy, ignore. How do you Clippy ignore again? By going to this link, I suppose. Shoink. Which server? Yeah, the Discord server. Checks for late initializations that could be replaced by a let statement with an initializer. How do you ignore? Clippy lints. Hold on. How do I ignore? I've done this before. Where is this? Do I have another window open? I do. Oops. Clippy. Shucks, where am I using this? Oh, allow. That's how you do it. Okay. Lovely. What one is it? Needless late init. Okay, now it's happy. Join, but if you're honest, you don't know how to use Discord. That's fine. I didn't either until a little bit ago. Cool. Yeah, Bacon or Stefan or one of you admins, if you guys want to make him a role, that's great. Yeah, we don't know how to use it either. Okay, expression. It's like Slack, but for like communities and gamers. That's kind of how I think about it. Although it's kind of different. So then the type. Oh yeah, so type is here. Oh yeah, we're already using that. Okay. So to do, so we have the value now. The value becomes the value. Awesome. Okay, so then the only thing we're missing is whether or not it's mutable, which we need a mutable thing. Let mutable. If it was a colon, then mutable becomes false. Otherwise, mutable becomes true. We need another one of these. But we don't need another one of these. Sure enough, we don't. All right, moment of truth. Are you using one AST for everything, including having typed AST? Well, I'm not sure what I'll end up generating later. Right now, this AST is just like syntax. It has zero information about semantics or anything. It's just representing the syntax. Oh my word, the tests are passing. Can you even believe that? All right. Tests are passing. So it's working. So the next thing I think I would reasonably want to test is like multiple expression statements, because I believe I'm just parsing one. So I'll fail. So let's try that. Am I going to allow implicit casting? Ooh, good question. You mean like floats to instance stuff? I don't know. What do you guys think? Test. Function multiple expression statements. And then we'll have something like okay, expect AST. If I had something like, I make something like foo, set it equal to 3, and then the next line I did like foo minus 4, right? Then this should be a program that is a vec of expression statement number 1 here has an expression, which is an expression variable decal, which is named foo, and its value is an int literal. No, it's a boxed expression int literal. 3. Is it mutable? No. The type is none. Is it discarded? Yes. See, that's passing. That shouldn't pass yet, because there's going to be another expression statement now. There's another expression statement, which is an expression. What kind of expression, you may ask? That's a good question. It'll be expression infix, no? Where the left is a box expression identifier foo.toString. The operator is an infix operator minus. The right is very much like the left, but fundamentally different. Int literal, and it's not any of this, it's actually just 4. Is it discarded? No, it's not. Alright, this will fail with a gusto, because we're only parsing the first one expression, we're not parsing the second expression. So we need to parse multiple expressions, which is going to happen in here, some sort of loop. So we'll just say while self.cur token isn't end of file. Okay, we need this. Let statements equal vec. I suppose this should be immutable. Ta-da! It's working. It's totally working. So now we're parsing variable declarations, which is fantastic. What should we do next? Function declarations or function calls? Function calls maybe are a little more straightforward, but let me commit first. Alright, get, wait, commit. Yeah, get function declarations out of the way. Sure, let's do it. What do we do? Okay, added semicolons. They're OCaml-like. And parsing variable declarations. And push that to Git. Okay, or GitHub. Coolio. So now we need to parse something that looks like this, which is just another type of. Let's make a test for it. Test function. Function, and they're expressions, right? Function expressions. So if I just make like expect, and this will probably have a bunch of cases because there's a lot of different ins and outs of how these work. Expect AST, like there's a lot of options, right? Having to do with like labels and unlabeled and stuff like that. So we'll say if I have like, what's a basic one? Like yeah, no body. Is this even legal with no body? Hey, real quick, can we decide how is unit gonna be expressed in my language? If I had like a returns unit, it's a fun that doesn't do anything. Returns unit, right? How do I write unit in this language? 0 tuple? But it's not a tuple. It could be literally unit. It could be void. I don't like void because void isn't what it is. It's unit. Unit. What about just the unit keyword, whose type is unit with an uppercase unit? I don't know. Or maybe that's nice. Unit. Make a poll. Well, okay, before I make a poll, what are our options, right? Probably between unit, this, void. Capital, no, not capital unit, because the type of it would be capital unit. I like the whole types uppercase, variables lowercase thing, you know? So I think the type of unit is of type unit with uppercase U, but the actual value itself is written as unit with lowercase u. These are all good options. I'll make another option. All right, here we go, poll. How do I do this? How should the unit, or how should unit be expressed? Like that. Unit, void, or something else. Explain. All right. There's your poll. It's between unit and the parens. All right, there's 20 of us on here. Only 6 of you have voted. I need some more votes. Unit seems more readable. Ooh, unit. Somebody just voted for void. Here we go. We're getting some more votes now. It doesn't represent nothing. Nothing is like nil. Nil is like nothing. Unit is like an enum with only one variant. That's why it's unit. Well, it's a deadlock between parens or unit. I'm leaning towards unit. I think unit's good. Stefan, what do you think? Yeah, really good point, Stefan. Fun. This looks horrible. This looks fine. Right? Yeah. All right, we're gonna go with unit. Obviously, if it returns unit, you don't need to specify it. So we'll do unit. So something like this, right? So I'm gonna make a function here that returns unit. Yeah, big U unit is the type. You put the type right here. So it returns unit. Like this is good. Oh, you're saying like that. Well, I think if we were using this as the type, true, that'd be like if we wrote the type as this as well. We could, in theory, make the type be unit and make the way it's written be this, but that just seems to me to be too confusing. Then you have like two different things. I think I like this. All right, so we got a function here that returns a unit. That's how Rust does it. Is this, no, Rust does this, doesn't it? This is the type. You don't write unit. Unit's nothing. All right, it's an expression. No, how does this work? It's a program that takes a vec of expression. Rust uses this as the expression that is unit. Yeah, but it also uses this as the type. It uses it for both. Expression statement. The expression is a expression function. Oops. Is it discarded? No. Yeah, you just omit the type, but it's the same as putting unit here. You see, that's what I'm doing here. There's no type. Yeah. The name. Oh wait, function expressions don't have names. Silly me. There's no name. There's no name. Okay, here we go. All right, parameters. Oh dear. Oh dear. Okay. Oh dear. Parameters. There's no parameters, right? It's like an empty vec. Return type would be none. That's not allowed. So maybe we have to write unit. I think this needs to be optional because this is only representing syntax and not semantics. So this is option type. Now none is good. Yeah, good point. Good points. The body is a vec, right? That returns, or that has an expression statement. Oh, do I actually make unit a keyword like in the lexer? Or is it just like a reserved name and it just becomes an identifier? Like, should this be a keyword or an identifier? Maybe probably keyword, right? I think it should be keyword. So we need to lex this thing. Yeah, I'm making true and false keywords. All right, we'll go into lexer. Let me get rid of this so it's not, so our tests are good. So I can write a test over in here. Our in tokens, we need a token. Keywords, we'll have a unit. Unit becomes unit. All right, and then let's add a test case. We have all this syntax. Let's just, add a random line here just to test that out. It's after the 33 semicolon. Here's 33 semicolon. All right, right here we need a unit semicolon. This says, yep, it's parsing it as an identifier called unit. We need to not do that. It should be like a one-liner. Where are we doing fine? Here we go. If we do unit, then it becomes a new unit. How long is that? It's 5, no? And now it passes. Okay, so now we're parsing or lexing units. What's going on here? Why isn't it 4? Because I can't count. Good catch, thank you. There we go. Yep, unit has 4 letters. And then, all right, so back to our tests then. Wait, but what does that become something in the AST, right? So what does that become in the AST? Its own thing? An expression? I guess it can be a unit. Is that what you're telling me? Okay. So then here, we're expecting which I guess we should maybe test up here. So let's test, where's like these? Here we go. This should be like test like unit. Discarded false. It's not an ident, but it's a unit. This fails because there's no prefix parse function for no prefix right here. So we had one more here for unit, which we could really just inline, but maybe for consistency we should make one. I don't know. Yeah, parse unit. Go down here. Let's make a parse unit. Self.expect token unit. And then that. There we go. Now it's passing. Now we can bring this guy back. It's failing. All right, the body has an expression statement. The expression is an expression unit. It is not discarded. That looks sort of ugly. Don't like how that's formatting that. Oh well. Hey man, new here. This all looks so cool. I subbed to your channel when you were building the operating system. Did you completed building the OS? Thank you so much for subbing. Nope, both are still in progress. This language is for the OS. I'm going to try to write the OS in this language. What difference would it make if it were discarded or not in that test? Like here? It wouldn't make any difference, right? Because it'd be returning a unit either way. Oh, wait. No, this would be an error. This would be an error. This is fine, I think. Yeah, this would be an error because you have to end with returning something. That's a good question though. All right. So we're failing because we have no prefix parse function for fun. Perfect. No prefix. Okay, let's add one for fun. If we have fun, then we do okay self parse function expression. Parse function expression. What's the return type on this thing? Result expression error. Expression error. To do. Hey man, I'm wondering what makes you want to make a programming language and then make the OS in that. Wouldn't it be easier to make an OS in C or ASM? It'd be really hard to make it in ASM, I think, but yeah, it'd be a lot easier to make it in C or Rust. Because I'm just doing this to learn and to have fun, mostly just to learn. So I thought I'd learn a lot more if I did it in my own language. So, by the way, from Tez. All right, parse the function expression. So where are we sitting right now? Where are we sitting here? Yeah, okay. So we expect token fun. Right? All right. And then what goes after that? We pull up yeah, no, there's no practical reason why I would want to make an operating system in my own language. It's purely just for learning purposes. And since I don't intend to like make any money or anything off this operating system, it's just yeah, I thought why not. So fun, and then we need to expect a left paren, right? So we'll do that. And then okay, then we need to start parsing these guys. Okay. So I'll probably have like a parse parameter. No? Yeah, okay. Okay, so I'm gonna say like until we get, so while self dot cur token bang equals that. How do I do it? Right paren. Maybe I should check also about end a file, right? Because every time I open a loop, I don't want to ever loop forever. There's a syntax error. Well, no, it'll be fine. Because I'll error if inside these, if I get, when I'm parsing these, if I get an end of file. Okay. Well, it's not a paren, say, okay. Well, let me return something here. Just so we're type checking. Cool. All right, and then, all right, so I'm gonna say, I need a parse function parameter that returns a result of function parameter or error. It goes to do. How do you make a new role, Kaya? Here, let me show you on stream. Go here. Go to here. Go to server settings. Go to roles. Go to create role. This is for 2000th member, right? So say 2000th member, and then a cool emoji like the dance one or something. And then you pick a color, like purple. No, that's already lead advisor. Blue. And then you don't want to display this one separately. Yeah. Cool. And then permissions should just be the default permissions, and then that's fine. And then you add a member. So I'll save these changes, and you can add the member. Oh wait, not 2000th member. It's 2000th sub. There we go. Sure, you're very welcome. Just go in here and add the right person. All right. Yeah, who's the 1000th sub yet? They were lost to history. Oh, you did? You got him? Oh, no, you got the 2000th. Cool. All right. Let me keep going here. So we have, where were we? Oh yeah. So in here, I'm gonna say, let parameter equal self.parse function parameter. We have a parameter, and then I'm going to say if self.peak, well, that should get us past it. So if self.cur token now is a comma, then I'm going to, if it's a comma, then I'm going to self.expect token, comma. So I'll eat that comma up. and then I just want to continue. Otherwise, here, wait, this is what I should do. Let parameters equal vec. Then here we do parameters dot push that. And here we'll do this. If there's a comma, then we'll keep going. Otherwise, we'll break, right? Does that seem like good logic? And then after this, we'll say, will you allow for variable declaration without initialization? Good idea. You mean like this? Probably. It's pretty useful. I'll add, yeah, definitely on the, do I have a to-do list? Support for variable declaration without initialization. Good idea. Yeah, I'm not eating the right brand. I need to do that right now. Self.expect token, right paren. And now we're hitting the right brace, and we're having troubles. So now we're through this in theory. Okay, at this point there might be that guy. We'll just ignore that for now. We need to expect a right brace or left brace. Eat the left brace, and now if I want to pull out this logic. Well, no, we can just loop through. Okay. Where are we? Function. Okay, we get a right brace, and then we'll do something really similar. It's like while self dot cur token bang equals the right brace. We will. Okay, I'll say let expression statements equals empty vec. I'll say expression statements, which I can rename to something shorter, like that. Dot push something like self.parse expression statement. We already have it. And then that should do something. And then we need to eat the right brace. So then the body becomes the expression statements, which I suppose we could just rename the body. And then do that. And it's passing. All right, so let's make some more sophisticated tests. Trailing commas, I don't know about in this context, but like in an array, well, I don't know, maybe it'd be nice. We can add that as add that later. It's not, I don't think it'll be too hard. Actually, I think I've done it before. So unit, like what if it returns 7 and then we specify int here? That wasn't a 7, but it was an 8. It's okay, that'll work. So then the body becomes, return type becomes type ident int. Correct? What's going on here? Oh. Expression statement is not unit, but it's actually an int literal 8. Okay, this should fail. Expected int y. It's not a good error. What? Oh, because this is totally not the right logic. There's not a... This should be like a message. Syntax error. Unexpected token. Now this error should be better. Unexpected token int. Perfect. That's the right error. Cool. So we just need to go in here and say, right between here and here, there might just be a type, right? So I'll say, so the printer just turned on for some reason. That's really loud. Okay. If self.cur token is a ident. Ooh. Okay. If let identifier equals self.cur token, then we'll say, okay, let return type equal none. Return type equals some type ident name. Then here we'll do that. So now what error we're having? Same error. Oh, that's not good. Oh, because we need to consume it. Dot expect ident. Cool, it's passing. So this works now. Let's try with some parameters now. Let's first try an okay, like something like x int x. Right, it's pretty basic. Function parameters is no longer this is labeled. Internal name is x dot toString. External name is none. Type is a type ident int dot toString. Cool. The return type is still an int, and the expression in here is just a ident. Otherwise it's the same. So we're getting a not yet implemented to for here, so that's from the to do here, parse function parameter. Why do I often forget syntax? I forget syntax sometimes too. If I haven't used a language in a while and then I come back to it after using something else, then I'm like always doing the wrong thing. Alright, parse function parameter. So we're trying to parse like this kind of thing. Okay, we're not going to do this yet. Is that okay? We're not going to worry about that yet. Just something like this. So I guess first thing we'll check is whether there's a tilde. So we'll match self.cur token. If it's a tilde, we'll do something. If it's an ident, we'll do something. If it's anything else, then we have a syntax error. Or unexpected, right? We expected parameter name. Cool, still getting these to-dos. How is this going to be implemented in the OS? Do you plan on using a backend such as LLVM or QVE or generate raw assembly? I'm going to generate raw assembly. Raw, x64, or NASM. Good question though. Okay, then we will, what do we do? Alright, so we're dealing with this case right now. There might be two. Okay, so I'm going to say like let first equal expect ident. Right, this will be a string. Now the next one might be one, or it might be a colon. So then I'll say let second equal okay, let second equal none for now. Make it mutable. And then we're gonna say if let identifier name equals self dot per token, then we're going to let second be some name. And we'll also advance. Like that. And then, so we might have a second one, we definitely have a first one. And then we're gonna expect a colon. And then we're going to expect, I really should have a parse type. Generating raw assembly is really complex, especially generating optimized assembly. I really recommend QB or LLVM because it does your heavy lifting in that case. Yeah, we've been over this a bunch of times. I'm doing this to learn, right? And not to try to make like the next great language, so I just kind of want to try it for myself. Okay, so yeah, I feel like I need to make a parse type. I would try pure functional languages like Haskell. Depends whether or not you count OCaml as a pure functional language. I've done OCaml. That's as far as I've gone functionally. Okay, wait. Expect token. Yeah. Well, I'll just hold off on the parse type because our types are only idents for now. Well, actually, maybe I shouldn't. All right, fine. We're gonna make a parse type. Parse type. Type. We're gonna say that should be the trick, right? All right, now where's that other place? Here. Let, I'm gonna do this, ty equals some self dot parse type, like that. Yeah, that worked. Okay. And then down here, yeah, this is bad. I'm gonna say there we go. That's better. We're still getting to-dos. yeah, this is even the spot I was dealing with. So that I do want that there, but I also want this, yeah, here, okay. And then I want to say let type equals self dot parse type. All right, now we got all sorts of stuff. So now we're gonna return, or we don't need to return, right? But we can just do function parameter. This is gonna be label.callSite. All right, the type is the type. Make it okay. All right. What's wrong with this? Am I not using it here? Oh, probably because it's unreachable. Okay. The internal name is the second one, or the first one if it's the only one. So if second dot is none. Also, okay, if let sum second equals second, then we'll do second ident. Then we'll do second ident. Otherwise, it'll be the first, right? The external name is just the it's kind of like the opposite, right? If there is a second one, then it's the first one. Otherwise, it's if there isn't one. Okay. Nope. Wait. Okay, that's a little bit messy, but there goes the printer again. Okay, so then, hey, it's passing. Let's make another one. Let's do internal, external. We'll call this internal, right? So this now, let's label that call site. The internal name is internal. This is some external dot toString. And then type is still that. Is everything else the same? Oh no, this becomes internal. This printer's being really loud. Hang on, I'm gonna go turn it off real quick. Okay. That is working, okay. And then we'll try this again, but with this, which shouldn't work, okay. Then we get function parameter not unlabeled. Name is X. And type is toString. Okay. And otherwise it's the same, right? Cool. And this fails. It says not yet implemented because we have to do somewhere. Sure enough, if we see a tilde, there's just a big ol' to do. So for my next trick, I will, yeah, okay, just try to do this. So this is even easier, right? So let name equal self.expect ident. So now we have the name. Oh, I know. First we need to self.expect token tilde. So that eats the tilde, and then we get the name, and then we self.expect token colon, and then we say let type equal self.parse type. And then that's all there is to it, right? So we return, okay, function parameter unlabeled at call site. The name is that, and the type is that. And that worked. Okay, so we're totally parsing functions now. How does that make y'all feel? I suppose I should try multi-line functions. Let's just do a simple one here. I'll try like there. That should fail. Okay, good. And then yeah, okay, the body is a little bit different now. We have an expression statement. So this is like a variable decal. Name is x.toString. Value is a boxed expression, right? Expression int literal, which is 8. Is it mutable? No. What's the type? It's none. And then there's another one, another expression statement. The expression is a boxed expression, right? No, we don't have to box those. Okay. Expression ident x.toString. Discarded. Oh, this one was discarded. The first one, this one's not. And it passes with multiple lines. Hey, enjoying your OS videos, planning on watching your language creation videos afterwards. Awesome. Yep, OS is definitely still in progress. The two are gonna hopefully merge at some point, right? Because I'm gonna try to write the OS in this language. Cool. Okay, so I think we're totally parsing functions. We're parsing everything here now except for function calls. At some point, trademarked. Yep. That was loud. What was loud? Did I bump the mic? All right, let's do. When you turn to the mic to reply like this, duh, like that. I saw in an older video you were using a window manager, possibly Yabai. Have you tried Aerospace? I'm really enjoying it. I've used both Yabai and Aerospace, but right now I'm not using either. You mean like this? This is just built into macOS Sequoia or whatever I'm on. That's just kind of what I've been using recently. And it gives you like 25% of what the others do, but it gives me like 80% of the functionality. I also have a few shortcuts set up with Raycast, so I can, like, if I have this smaller, for example, then I can hit like Alt, comma, and it'll make it the full size. So yeah, no, but I've used like a bunch of different ones. I used Yabai, I used Aerospace, I used, what was that new one? Like Flash Space or something. I feel like there might have even been a fourth one, but I just never quite. Most of what I used them for was like full screen like this, because I'm usually just like editing, and so I wasn't quite getting all the use out of it. Cool. So let's parse function calls. So I'm gonna make a new test. Function calls. Expect AST. We'll do something like add 3 or print 3, we'll say. Gotcha. I like having terminal in T, browser in B, notes in N, etc. Yeah. But do we get the functionality with built-ins? That's probably better anyway. Yeah. Well, no, I get what you're saying. So I also have like I have Figma over here. This is where I make my thumbnails and stuff. And that's like option. I have like some key maps set up. That's option 4. This is option 3. And I have that set up for like all 3 of my monitors. So different spaces have different. JMS, please no spam. All right, so print 3. Okay, I was gonna check to see, do I have this in? Yeah, I do. Okay, so I'm gonna make this be a program, which is a vec of expression statements, which the expression is an expression. Sorry, I forgot a P. Expression function call. Discarded. This one's no. The name is print. The arguments are a vec function argument. What do I have here? Argument. It's just called an argument. Okay. Argument. Has a label and a value. The label is none. The value is an expression int literal 3. Cool. What's the error we're getting here? Syntax error, invalid operator. That guy. Shwink. Invalid operator. Here it is. Okay, so where do we do this? Do I see a little Swift inspiration in the external name variables in the function signature, or is that common elsewhere? That is totally straight from Swift. Yep, good eye. Why don't you support expr in parentheses? That feels weird. Can't I do 1 plus 3 times 4? Yeah, I do. That works. Do you see somewhere that suggests that that doesn't work? It should work. We have this passing test case that's like, this thing is working. All right, what am I looking for here? I forget what I was doing. Oh yeah. It's right here. Yeah, okay, it's in here. So if you have an identifier and then a colon, okay, so if we have identifier and then a left paren, then we need something else. So if I have a left paren, then I want, okay, self parse function call. Variable declaration, grouped expression, we'll put it here. Parse. Hi, how'd the work going? At what step of the process are you at now? Parser and AST? Yep, parser and AST. We're working on the parser. Parse function call. Returns a result of an expression and or an error. Now we should get this. Instead. Sure enough, okay, that's better. Now we're getting high. Will you have generics? Yeah, there better be generics. I couldn't live without generics. To do. All right, so how do we parse the function call? So we're gonna say let name equal self dot expect ident. Then we're going to say let and then we're gonna self dot expect token left paren. So you need to parse that in your function deck, right? Yeah, but we don't have them yet. I'm just taking things one step at a time. There's a bunch of things. Like I'm not parsing generics even in like types yet, so yeah, but there will be, I'm hoping. Then we expect a left paren. And then we need to parse. Wait, so I made it parse function parameter. Okay, so I need to parse function argument now. All right, so I'm gonna make function parse function argument. Result expression, no. Argument error. going to rename this to function argument. All right, so then I'm basically going to do the same thing with like the comma that we did here, right? This like exact same thing. I'm going to say let arguments let mut self dot vec, and then this becomes arguments. You think Rust is slowing me down because it expects you to build perfect code while you're just testing an idea and looking if it just works. Well, I do want this to be pretty high quality code at the end of the day. We have arguments. This becomes parse function argument. And yeah, this is like the same thing. Now we're getting this guy. This guy. Ooh, okay. So this is a little bit tricky, but it's not too bad. And then at the end of here, we'll just say self dot expect token right paren, and then we'll return expression, or okay, I guess expression yeah, Rust does make you write good code. I think that's a good thing. Okay, expression, what kind of, what is it? Function call, which has a name and arguments. Okay. And then we just need to parse function arguments. So we'll say if let name equals self expect cur token to fire. Then we know we have an identifier here. Now that could mean one of two things. It means either we pass like an identifier in like that, or we have a label. So we need to, if peak dot peak token equals colon, then we have a label going on. So return function argument. The label, yeah. The value is an expression. Actually, this should be none. Okay, and then if we have a colon, then we'll say the label becomes name. Okay. And then we will self.ex. Well, I suppose we should eat the expect ident here. And then this would become the cur token. We're also going to need an else block here. Okay. If we have a colon, then we want to eat the colon. And then we're going to say value equals self dot parse expression lowest precedence. And then if there wasn't a colon, then we'll say, it's a little messy. If there wasn't a colon, then that means we just genuinely have an identifier as the value. So we'll say value how's that? And then in here, this means there was an identifier, so then we just say like value equals self dot parse expression. And that's passing. And if I do 4, another one with no label, but this one's 4. That works. If I do this 3 and 4, then this one becomes that. Needs to be sum. Wow, it totally works. So now we're officially parsing all existing lovely syntax. Are we in agreement on that? It's pretty cool. Parsing functions and function calls. Awesome. Should all be there on GitHub now. Lovely. Yeah, parsing functions and function calls. It's a lot of code. Awesome. Well, I'll probably stop there. That seems like a good stopping point. No? We're parsing everything that we have. So next stream would be adding more syntax and lexing and parsing that, or starting to actually compile this, or writing a tree sitter grammar, which I really want to do because that's pretty easy. Cool. Yeah. Well, I'll stop it there. Thanks everybody for getting on and helping out. So see you next time.